everyone, and welcome back to today's episode on Learn All Things Cyber with T. So for today, I would be going into a new topic, and I would say you should brace up because it's one of the most difficult topics when it comes to cybersecurity. I won't be going deep dive into it. I will be sharing basics, and I'll be recommending further material, extra materials that you can read in order to have a better knowledge of it. So the topic is computer networking. So we're going into computer networking. So I'll be sharing with you what a network means, fundamentals. What do we regard? So in security, when we talk about a network, what are we referring to? And I would also share with you what a network component is. I'll share with you network geography, and then later part of the course would look a little bit over OSI module, which is like a framework that is done by ISO. So this framework helps with how devices communicate over a network. So it's also connected to computer networking, and that's why I'll be taking it this week with you. And then would talk about TCP/IP, which is like the current framework that is being used. So OSI module is like a reference module, and then TCP/IP is what is generally known now, and I'll tell you the difference between them. So stay tuned. So basically, what is a network? So a network is a group of connected devices that share information with one another, that communicate back and forth with each other. So let's see it the same way as we say networking in English language. So you meet with people, you connect with them, you share useful information with them. That's what a network in security also means. So it's a group of connected devices. When these devices connect with each other, they communicate with each other, they share information back and forth with each other. And then let's quickly, try to go into some of the components. I discussed this before when we're talking about, security devices and technology, but we adding few devices also so that you can, understand it better, because sometimes we mention some things in security and people are like, I don't know what that means. You know what that means, you just don't know that's what they are referring to. So for network, So for network components, what are the components that could make up a network? So we have things like clients, we have things like servers, we have things like switches, we have things like hubs, we have things like IDS, IPS. If you remember properly in previous lessons, I mentioned these two. We have something like load balancer, and I would explain what that means in a bit. So basically, these are like very few network components. We have a lot of them, and I'd highly recommend a course on Udemy, the on training on Network Plus. It's very detailed when it comes to computer networking. They go into network topography, into even network security, which is very important for people that want to grow their knowledge in security. So what is a client? A client can be a device, and it can be a software by which you request resource from a server. So say for example, you want to request for a PDF file. So you request from your phone or maybe through an app. So from your phone or through an app, those are called clients. So clients could be your workstation, it could be your smart TV, it could be your bank app, it could be anything that requests resource from a server. So then what is a server? A server gives resource, provide resource back to the network. So say for example, I want to go into, try to browse what is on the website, or, check few things. I request through my clients. The server, like say web server, for example, we have so many of them. We have email server, we have file server, we have web server. So let's say for example, web server, you're trying to get something on the web, then you request for it. Let's say you are saying, what is the meaning of this? And then the server, the web server, would provide you with these resources that you have requested for. So what is a switch? A switch is like, say, we have something that holds together connected devices over a local area network. Say, for example, my computer is connected to my printer and connected to other devices, or my phone is, connected to something else over a local area network. And I will explain what a local area network means. It means, you know, it could be in your home, it could be in your office space and stuff like that. When we get to network geography, I try to explain, you know, all of the geography we have when it comes to networking. So what is a switch? A switch would hold together every connected devices. So say for example, I'm trying to print a file from my laptop. I'm trying to print a file on a printer. So the switch that connects the laptop and the printer will then read the MAC address, and I will explain what MAC address means later in the lesson. Will read the MAC address of the printer and then send the file directly from my laptop to the printer. It will send it to any other device. Even if you have like 5 or 6 printers, it will send it only to the printer that you have forwarded that file to. And this is where, you know, switches are different from hubs. So usually in security we call switches a smart hub. So say for example, if you're sending something, if a hub is connecting devices together and you're trying to request for something or send a file over it, a hub will send it to all the devices on that network. It will broadcast it. That's the word we use. It will broadcast it to every device on the network. But for a switch, it won't. It will send it directly only to where you want it to be. And you know, hubs are old. People don't use hubs anymore. So IDS, IPS, you already know what they mean. I've mentioned a couple of times. Intrusion detection system, intrusion prevention system. They could be also part of the network component. Like I said again, a network is like a group of connected devices that share information with each other back and forth and communicate with each other. So what is a load balancer? A load balancer is like a traffic manager, and it handles incoming network requests. Remember we said that a client actually requests for resource from a server. So what load balancer does is that it handles this incoming request and spread it over multiple servers. So for example, you know, a lot of requests are coming from customers, you know, to probably a bank, you know, hub, whatever it is. What a load balancer does is when there are various type of servers, it spreads the request across so that one server is not overloaded and then leading to crash. And this helps with, you know, availability. Like we said, that availability is when, you know, you have that information available to you as an authorized user at any time that you need it. So load balancer helps a lot with uptime and, you know, availability. Again, load balancer is a traffic manager. It helps to, you know, put incoming requests and spread it around instead of, you know, loading it over one server. So when you have a load balancer over your network, it helps for servers to have all the requests equally, so no server is overloaded. So for network geography, as I said previously, we have about 5 of them. I think 3 of them are quite popular than the other 2, but I'll mention every part of, you know, every type that we have, so that when you hear it in the future, you have an idea what it is. So for network geography, this is, you know, based on location, like, you know what geography is, based on location, distance. That's, you know, the connection of your devices based on how distant apart they are. That's what network geography is referring to. And we have about 5 of them, like I mentioned previously. We have personal area network. We have local area network, like I mentioned before when I was explaining about switches. We have campus area network, and I would explain this. Campus area network. We have metropolitan area network. And we have wide area network. I'm sure many of you know this wide area network. So area network. So personal area network is just, you know, the connection of devices around your personal space, like the name implies. So say for example, the connection of your, you know, the Bluetooth between your phone and your smartwatch. That's personal area network. It's usually less than, you know, 10 feet. Say for example, you spread your hand around, anything you touch, that's around your personal area network. Local area network is what we experience in our home and in the office space. Like I mentioned before, that a switch will connect devices, a group of devices together within a local area network. So your Wi-Fi, you know, connecting your smart TV, your phone, your laptop is a local area network. And for campus area network, say for example, a campus area network is like a group of, LAN. We call this LAN. So a group of local area networks. Say for example, in a university settings, for example, we have mathematics department, geography department, different departments. So each department might have a LAN that is connected together over a campus area network. So it means that anywhere you are in the campus building, you will still be able to connect, to other parts, even though, it's like a chunk of land that is put together for campus area network. For metropolitan area network, they are usually like connected across a city or across a county. It is smaller, not up to what wide area network. Wide area network would be you connecting over different states across the country, and this is where internet comes in, because we could use internet to connect devices across the ends of the world, and this is wide area network. MAN is just across city, across a county, and the rest. I hope this is comprehensive enough to give you an overview of what network geography simply means. So, like I said previously about OSI model. So what is OSI model? The meaning of OSI is open system interconnection, and this is like a framework and it's done by ISO. ISO is the international standard that deals with things related to security, but that is history. We are not going into the history. We want to talk about the model itself. So the model is like a reference model that is being used for how computers or devices communicate over a network. So communication of devices over a network, this is a framework that governs how they communicate. So we have, it's like a layered cake. Let's talk about cake. So it's like a layered cake. So we have different layers of them as I've listed on the board, and I would explain them one after the other. And when I finish explaining them, I'd also explain the analogy that is connected to them. So the first example, the first layer is actually called the physical layer, and this physical layer actually deals with the physical devices themselves. Say for example, the cables, the routers, the fiber optics connection. So everything physical regarding communication of devices over a network actually stays in the physical layer. And normally, because there are transfers of data around, when it comes to physical layer, data is actually called bits. So bits is like in ones and zero. And this is what physical layer understands. Like it's either 1 or it's 0. It's that the switch is up or the light is up or the light is off. And you'd understand this a bit better down the line. So the second part is the data link layer, and this is the layer where devices communicate using something like MAC address, that they communicate with each other. I mentioned this when I was referring to switches, that they communicate with other devices using MAC address. So switch actually falls in this layer. So, and then the data in data link layer is actually referred to as frames. So we don't call them data. We don't call them that, the devices are transferring data. We actually call them frames. So frames are being transferred from one device to another. So this third part is the network layer. And it is this network layer that devices communicate with each other using IP address. I'm sure you are familiar with this. And this is where the internet comes in, where one device will communicate with another device using IP address. And usually we call data in this layer packets. We call it packets when a packet is moved from one end to another. For the transport layer is what ensures that this data that is being transferred is delivered completely and correctly. So in this transport layer, we have something called UDP and we have TCP. And so the example I'd like to give when it comes to UDP, the full meaning of UDP protocol. So the example I'd like to give is, for example, you're watching YouTube. So when it comes to UDP is always very fast. Is a fast part of transport layer, but it doesn't mean that the data will be delivered completely and correctly, but which is different from TCP. TCP actually ensures that the data is delivered accurately, and this is when you request for a file, you'll be able to get the file completely, delivered to you and all of those. But for UDP, you cannot guarantee, but it's quite fast. It's quite faster, and that's why it is used in streaming, streaming of video, live streaming of video. So as you can see from the screen, the difference between TCP and UDP that I was explaining. So TCP is secured, it's connection oriented, it is slow, like I mentioned, compared to UDP, which is fast, which is usually used for, you know, live streaming of videos and all of that. You can use it for YouTube. But I specifically want to talk about something called three-way handshake that you can see with TCP and is not present with UDP. So the next image you'll be seeing is this you know, three-way handshake, and I'll be able to explain it. So basically, like I said, that I would be explaining what three-way handshake means. So in the first step of it, which is a synchronize, it means that the client, you already understand what the client is from the beginning of this video, and the client wants to establish a connection with the server. Imagine that the client wants to request something, the server produces the request to a resource. So then the clients themselves send a segment. Don't forget what a segment is. A segment is what we call data when it comes to transport layer. Send it to the server, and then the server responds back to the client's request with a SYN-ACK signal to say that I acknowledge, you know, that you want to request something from me. And then the final part is where the client also acknowledges the response of the server, and they both establish a reliable connection. And this is where TCP is actually different from UDP. So for section layer actually ensures that it opens, maintain and close communication. An example for section layer will be Zoom, and from this layer downward, or I'll call it upward, data is actually called data. So it's like saying you're communicating and transferring data from one device to another. So for section layer, it actually opens and maintain and close communication. So if, for example, Zoom, if you're on a Zoom call, you don't go out of the Zoom meeting until you leave yourself. So it opens it, it maintains it, keep it running, like keep your meeting running until you actually go out of the meeting or end the meeting. That's when it closes it. So it keeps it confined and then closes it at the end. So for presentation layer is the layer that converts whatever information you're requesting into a readable format. So when you're requesting for a file and then you get the file in JPEG or you get the file in PDF, then you're utilizing the presentation layer. For the application layer is the layer you actually, as a user, interact with a lot. So say, for example, I'm trying to know what is cybersecurity on Google Chrome, and then I get the results back. You're utilizing the application layer. And like I said, they are all data. So I'll share a little bit of analogy with you so that you can better understand how these layers, you know, function. Okay, so let's say physical layer. I'll explain it based on the concept of a letter. So physical layer, the postman would actually pick up the letter. Like say, for example, I wrote a letter. I'm writing a letter to my friend. The postman comes to me as a sender and pick up the letter from me. And then the data link layer is where the letter itself carries the sender address and the receiver address. So you cannot really send a letter if you don't put your own address, just in case it is not delivered, then the letter can be returned to you. So you need both addresses, and this is the function of data link layer. So for the network layer, it's actually the layer where the letter then moves cities. Say, for example, my friend lives in Miami, I live in Chicago, you know, that type of thing. You are actually sending it and it's moving across. So, you know, the letter will go maybe from your local post office, intercity, and then before it gets to the city of your friend. This is the network layer. And then for the transport layer, this is the layer that ensures that my letter will be delivered to my friend, to the receiver. This is transport layer. For the section layer, this is the layer that handles, you know, multiple conversation. I'm not the only person sending letter. There are multiple people, maybe 1,000 people that are sending letter. So section layer is what ensures that my letter gets exactly to where I'm sending to. Other people's letter will get to where they are, you know, there won't be mixture of letter, you know, my own letter getting to someone else that I didn't send it to. Section layer actually handles that. Presentation layer is what will convert my handwritten letter to readable text. Say, you know, I wrote a letter, but, you know, if the letter is not readable for the receiver, then it's of no use. So presentation layer is what converts, de-encrypt whatever I had written in that letter to the receiver, so it will become readable. And then the application layer is the actual part where the receiver receives the letter, reads the letter, and understands the letter. I hope that makes sense. And then how this OSI module is different from TCP/IP module, which is like a different part. Basically, like I explained what OSI module means. So because TCP/IP module is also a module that people talk about when you explain OSI module, so I try to show you the difference between them, and I would also explain, you know, in a simple analogy what that difference between them means. So like we said, you know, we mentioned that for OSI module we have application, we have presentation, we have session layer, we have transport layer, we have network layer, we have data link, if you remember, and then we have physical layer. So in the case of TCP/IP actually combines both of these and then call it network access or network, and then calls this one internet. It leaves the transport as transport and actually combines all these three and call them application. So as we have explained before, TCP/IP actually deals with everything in the physical layer, how data, how communication is happening over the network using MAC address, like we explained. The network is how devices communicate with each other with IP address, internet protocol address, and that's why that's where the internet came from. The transport, we said, it's what decide that this data will be completely delivered and accurately delivered and all over the network. And then for session, presentation, and application, TCP/IP just sees them as one application. Now, what's the difference between both modules? So for OSI module, when it comes to letter, again, I'll use the analogy of letter because it's easy. So OSI module actually focuses on packaging of the letter, labeling of the letter, shipping the letter, and eventually delivering the letter, like I explained. But TCP/IP is a more practical step, which is like 4 steps. So this is like 7 steps. This is more practical steps that is focused on shipping steps. So usually OSI module focuses on plenty other things, but TCP/IP does a lot of focusing on shipping. So that's how I can give the analogy when it comes to letter. And I hope you enjoy this week of Learn All Things Cyber with T. I'll see you next week, and we'll be discussing the topic around ports and protocols, then IP addressing itself. So we'll talk a lot about IPv4 addressing. We'll do a little bit of calculation around IPv4 addressing, and a little brief on IPv6 address. And for those in Africa, not sure whether IPv6 is in use yet, but it's something that would eventually come. So we'll briefly talk about it. See you next time.